Hi guys, welcome to a new video where we will talk about cloud integrations with photon particle. The best demo to show you this is to control the LED, and what we're gonna do now, we will control the LED using mobile phone Tinker app. As you may recall, in some of the previous videos we toggled the state of the LED using the serial communication using a PC, and also we toggled the LED state using buttons. So we covered all three states, and now we're going to use a mobile app to do that. Physical toggling using cable, and toggling using mobile phone. Tinker is a mobile app that requires special kind of firmware. It's called the Tinker firmware that exposes the pins to the cloud, and this mobile app is using the cloud to control the LED. And you have the complete pin control, and this is kind of the IoT-ish concept of everything, because you have interoperability between various systems. For example, you have a mobile app and a device communicating with each other, and that's kind of the essence of IoT. You can download Tinker from Play Store or Apple Store. Just search, I think searching for particle will do. Anyway, we will toggle the LED. To do that, let's make a short circuit, not a short circuit in the terms of short circuit, but a simple circuit with LED and I will put this on a D, for example D2. So simple circuit with one LED, just fix those there, it should be fixed. Simple circuit. Maybe I should expose ground. Let's do this because I will need more ground later on. So this is the ground connection. Because we are using SparkFun edition, we cannot use mobile app to Tinker. Let me show you here. I have it here. It's called, let me just turn it like this, it will be fine. So I have my TD1, and there is a Tinker tab on top. Unfortunately, you cannot flash Tinker because it says it's not supported. So in order to flash a Tinker, you need to open yourself console.particle.io. It will open a console with all of your devices. You need to log in with the credentials of your device, of course. And here in the list you have, mine is TD1, here it is. Once I click on it, I can flash Tinker. Or I can see if the Tinker is flashed. I don't see it's flashed because it doesn't have exposed any functions for the Tinker. If you want to flash, you need to click here on Web IDE. It will open the web version of editor for the code. And here in the list, you have all the apps already present on let's say my account. You have Tinker, or you can click here example app. It will then click use example, and then you can actually see the source code of it, of course, and you can flash this one. Make sure that you have selected device. I have TD1 as selected device, and flash. You can check here, you will see that it is flashing a firmware, special kind of firmware. And once it's done, head back to the app and you can actually pull to refresh. It should state, let me see here, Tinker. So this tab menu changes and you can actually see the whole board, kind of whole board. Let me just try to, so you can see everything here. And first things first, D7, tap and hold, tap. And here, I don't know if you can see, it says digital read, digital write. I will use digital write and check here on D7. Once I tap again, I can toggle the D7 state on and off. Also, because I have connected D2, I will use also D2 to control this LED here. Once I tap on D7, it turns on. Tap again, it turns off. So this is the Tinker app. Imagine what you can do with this, but I would like to I would like you to think about this. What's going on here? It's pretty amazing. First things first, my tablet here, running Tinker app. Once I pressed here, the information travels to my router, to my internet service provider, then probably to some servers in Germany, then goes back from Germany to my internet provider, to this router, back to this device to turn on the LED. So my tap traveled across Europe just to turn on this tiny LED, which is quite remarkable if you think about this. Just to turn on the LED, all the effort, but it's awesome, and that's why the IoT is so cool. Let's move on. So now you know how to control the LED using your mobile app. No coding required in this case. And let's talk about cloud. So when I say the server in Frankfurt, probably that's a cloud location. What you can do with cloud is device can send data to the cloud, and this data or information can go to another cloud, to another device, to another application, whether that's mobile or web. It doesn't matter because everything is transparent in this field. So what can you put on a cloud? You can publish a variable. Imagine a variable in your code on your firmware can be published to a cloud, and everyone can access the value of this variable. Also, you can publish a function, and you can publish an events. And all this is very REST friendly, REST friendly. It means that it is very interoperable on that level. So what are events? So if you want to publish event, then you would use syntax particle.publish with the following parameters. The first parameter is the name. It's a string value up to 63 characters. The second parameter is data up to 255 bytes, also string value. The third parameter is time to live, which is not used, it's 60 by default. And the last is visibility, whether your event is published or private or public. It is good to note that the events are matched by name, and public events are visible to everyone, and you're only allowed to have one event per second. Of course, you're allowed to have bursts of 4 events in a second. After, you have to have a backoff period of no event transmission. What we're going to do now, we will publish an event when button is pressed. To do that, I will probably need a button. So a button here. Let's leave this LED here, it doesn't matter. A button, and let me connect this to let's say D3. There, simple button. In case you're wondering why is this LED not being on all the time, because I have a faulty connection somewhere, very faulty. I don't know which part. Checking all the wires. It should do just fine. So we will publish event when the button is pressed. You will not see anything special about this. However, let's head to our Visual Studio Code. I already have some code here which I will comment, because we will actually we will use this code to explain the button publishing of events. First things first, pin declarations. I'm using D2. Actually, the button now is on a D3, so I'm going to change it here to D3, and the pin LED is going to be this D2. I'm using interrupt for the button, using interrupt service routine, something that we did in previous videos. And in the loop, I'm just listening whether the state has changed and counting the number of button presses. And once that is done, I'm publishing this number to the function. So each button press will increment number by 1. So let's flash this code, Cloud Flash. There are multiple ways to see the events. The first and most easy way would be to check it on a console here. You can see all the events being published here. Also, you can check it on your particle app, where you can also see all the events. And that's exactly what I'm gonna do now. If I press this button, you can see button press event being published. Also, you can see it on a web page. Maybe it's more readable. So if I press again, data will be number 2, and press and press and press. I can spam it, and at some point in time I will get blocked because I'm overusing the service. Obviously, they are not strict about the policy, but be aware, so you're limited 1 event per second. At some point this will stop. So this is how you publish event. And you might wonder, okay, I have the event, but what can I do with it? Well, it's a very, very cool thing here. If you check it on a console, you have integrations, and you can add a new integration, just a simple webhook, and whatever event can happen here. We have event name button press, and it can automatically invoke some service using any of these REST methods. And of course, you can do a lots of advanced multiple events and so on, but basically that's it. So once the event is published, it can call another service with the data from published event. Simple demo. Just publish event when button is pressed. Next, subscribe. I will not do this demo because it's obviously it will work. What is very convenient here, because you have particle subscribe, the parameters are name, it is an event prefix, not the event name, and the handler is a name of a function which is void type and has 2 parameters, string name and string data, and you are allowed to have maximum 4 subscriptions. However, because they are using event prefix, for example, if you have event 1, event 2, event 3, and you subscribe to just event, your handler will handle all 3 events, 1, 2, and 3, because they have a same prefix called event, which is convenient if you need more subscriptions. The next cool thing that you can publish or put on cloud is a variable, and the syntax to publish a variable to the cloud is particle.variable with the parameters name and the variable name, and you can have up to 20 variables published to the cloud, and it is very convenient because the particle ecosystem is automatically updating the values of the variables that are published to the cloud. And you're only allowed to have integer, double, and string as data types for the variables. And for those of you who are familiar with REST, this is the get path for each variable. So you need to know your device ID and variable name, and this is how you get the variable. The next thing that you can publish on the cloud are the functions. Similar as a variable, you publish a function using particle.function name. The first parameter is name, the second parameter is name of the function, and the function here has to have the following signature. It has to be integer type and one parameter called data string type. And you declare this in the setup. Also, you declare variables in the setup as well, so you don't have multiple declarations. So in this demo, what we're gonna do, we will toggle the onboard RGB LED, the one that is now breathing. If you check it out, it's breathing cyan gently, and we will expose that RGB. We will control that using particle cloud functions, and we will retrieve the current value using variable. And I already have the code prepared here. I'm just gonna uncomment that so we don't lose. There's no need to type. I will just explain it a bit. You may already see that the loop is empty because everything is done in the setup. First things first, I'm declaring myself as 3 string variables, RGB, and I'm declaring current color string. This is the one actually that I'm gonna publish to the cloud. Here I have some helper variables for slicing, parsing the string. I'm using manual parsing in this demo. To control the LED, RGB LED, you need to call a function called control that's over the RGB object, and you need to pass the parameter through. This will indicate the board that your firmware is in control, and only then you can change the color. So this is the color black, no color. This will turn off the LED. So initially I'm turning off the LED, and then I'm calling particle function. This is the function name on the cloud, and this is the function name in my code. You can see that it is integer type and it has string data. And I'm also calling here particle.variable that will publish my current color variable here on top, which is string, under name my current color. I could have used the same name, but this is on purpose, just to see that it doesn't have to match the name on the cloud and the name in the firmware. And controller RGB is a function that is doing the following. Let's assume that the data that we will send to this function has the following format. So this is red, green, and blue, separated by comma. And here I'm just searching for commas here. I'm gonna just so I'm searching for index of first comma, and the last comma index is actually the second comma in this string, and I have the location in the string of the first and last comma in the variables first and last. Then I'm using substring because I don't know, in higher level languages, I think in C#, the substring is actually using the number of characters to return. Here it is just using the indexes, first index and the last index of string segment. So I'm getting from 0 to until the first, it's 128, and I'm storing this into R variable, which is for red. And then I'm going from the first index plus 1 all the way until the second one, I mean the last one, to get the green component. And the blue one is just from the last until the end of string, so I don't put any parameter here at the end of the string. Then I'm setting the current color. I'm using this concatenation with the plus sign to get kind of formatted string for the current color, which is again published to the cloud. And then finally I am storing the color. I'm actually changing the color of RGB by converting those numbers stored as string using toInt method of a string class. And in the end I'm returning 0 because I need to return something because it's an integer type, and then I can cloud flash. The device is flashed. You can check here the RGB is turned off. And let me show you the functions. Here you need to refresh because it's not refreshed, and the variables you need to also refresh and call get here. Failed to fetch. Let's see. 50 and 50, it will be some kind of whitish. It is. Yeah, now I can get the value. I can change the number. I can make it full red. 255, 0 and 0. Once I click call, check on the board, it should be red. It is red, kind of reddish. On a camera is making it more look white, but trust me, if you try it, it will be very red. And of course, if you call get here, you will see that it is red color here. And that's it. This is how you control the RGB in the first place, and this is how you use photon particle cloud for the functions and variables, publishing the variables. And now let's head back to the very cool feature. It's called IFTTT. If you haven't used the IFTTT, prepare to be amazed because this technology is awesome. They did have some changes lately, especially in their monetization models, which made many people unhappy. However, it's still free at some point. So IFTTT stands for if this then that. It's a trigger action model. It supports triggers and actions on multiple channels, including Samsung, for example, Google, Android. They have Amazon, Alexa. Every single thing that you can imagine is probably on IFTTT. I will show it to you, and it's free. Still free, a bit. And let's check it out. First, let me open the IFTTT web here. I mean, I will not. It's not my job to promote the IFTTT. I just respect it because I use it very often. And of course, there are many alternatives, including Zapier, I think. But so this is not sponsored video in any way. So the IFTTT has the following applets. I mean, I have my account here. You should probably create yourself account. And I have my applets. Let me show you example. So this is one applet. If every hour, every complete hour, turn off the iron. I have a smart outlet called the iron, iron. And what is happening is my girlfriend, unfortunately, she forgot to turn off the iron, and then I made the applet that is turning the iron every full hour just in case. And the funny thing is that I didn't tell her about that, and she was surprised that iron turned off, because she was probably doing the ironing at 00 as it was here. So this is one of the applets I have here. Let me show you how to create a new applet with the particle, which we do have here. Let me see. So this is the dialog to create the applet. You need to choose a trigger. And here is the list of all the services that you can use for IFTTT, as in this particular case as a trigger. And I don't know what's, oh, this is interesting. Look, a space. It's a channel by NASA. It's amazing. So there is I used to have this. If ICC passes, ISS passes over a specific location, trigger an action. And I created the applet for that, and actually you can see it worked. And I was so you get a notification, of course, and then you look up in the sky, you can actually see the ISS zooming across the sky, night sky especially. I love the applet they created. However, the problem is that ISS is very fast. It happens here, it says 15.5 orbits per day, which is a lot, and half of these actually happen during the night when you're sleeping, and that's why I turned it off. Another one that I used to have a lot is image of a day. Once the NASA publishes an image of the day, you can create an applet that takes this image and set it as your wallpaper on your phone. That's a cool applet to have. Anyway, let's head back to the list of all the applets. I'm gonna choose which one? Battery. I have Android battery. Device is plugged in, device is unplugged. I don't know how I'm gonna demonstrate because my phone is the one recording, so this one is not going to be useful. Let's check something else. I mean, I can always use Google, but I don't like it. There, Google Assistant. Say a simple phrase. What do you want to say? Set red color. Oh, let's try this. This is more awesome. Say phrase with a number. That's cool. What do you want to say? Set red to. And now use the hash sign as a number ingredient. We don't have any options. What do you want the assistant to say? Setting the red, my lord. English language, create trigger. There, and then I will choose here particle. I already have it linked to my account. If you're using this first time, you will probably have some screen saying connect, and you probably need to log into your particle account so you can get to this screen here. What I'm going to do, I'm going to call a function, and now it will ask me which function, and I will use it like this. So this is ingredient. Number field, of course, you can have ingredient, two ingredients created at a number field. I have a number field, as you may recall, this is RGB separated red, green and blue separated by commas. And let's create an action and click next, continue. I don't want to receive any notification, and now I will click finish. Need to give it some time. And fingers crossed. Let me check if my tablet is set red to 6. Oh, that worked, kind of. Let me show you here. Let's move it. Hold on. Set red to 100. I'll wait for it. Set red to 100.
Setting the red, my lord.
And you can see it's more bright. Hey Google, set red to 0.
Setting the red, my lord.
There, it answered on another device. I have my Google Assistant here as well. And let's move on. So this is how you use IFTTT. You can always use this in your IoT projects. And it's very convenient because you can connect various services using the IFTTT, and it works. So I have connected Google Assistant with Particle Board here, with of course zero coding, just using a third-party service like IFTTT. This is it. I hope you learned something, and I hope that you will try the services and to make something awesome. See you next video. Bye.